Welcome to another episode of That's Absurd, Please Elaborate, a podcast where we talk about science things most of the time, but also try and make each other laugh using questions that you send in. I am Trace, one of the hosts of this podcast, and Julian, our other host, is off this week, so we have a guest host here with me, Ceri Riley. Hello, Ceri!
Hello! I may have mailed Julian some plane tickets on a vacation so that I could take his spot and hang out with you, Trace, because I feel like I only hang out with my science communication friends when we're making something together.
I can feel that. That feels like, I don't know if that feels good or bad, that we only hang out then. We sometimes hang out at conferences and stuff too, though, which
true.
is fun. If you go to conferences, sometimes I do.
Mm-hmm. Sometimes I do. I run into you by the food trucks. We eat a meal together. It's great.
Food trucks. If this is the first time you listen to this podcast, audience member, we answer questions from our audience using as much science as we can muster, or at least, our intuition can find. Both Ceri and I are science communicators. Julian, who's usually here, also science communicator, and we spend our time doing research, figuring out the answers to these strange, absurd, outlandish questions from our audience. If you want to submit a question, go down into the show notes. You can find all sorts of ways to do it. You can email us. You can go to our website, that'sabsurdshow.com. You can even call us now at 302-TAPE-SHOW, TAPESHO, and leave us a voicemail. If you are a Patreon member, which I hope you are, thank you. And I just want you to know, you can join our Patreon and vote on potential questions that we might answer here on the podcast. So that's super awesome. You can join the Patreon. Look for the link down in the show notes as well. But I think let's just jump right into some questions, Ceri. What question do you answer this week?
So you sent me a plethora of questions to choose from all your wonderful listeners. They've got such weird brains. I love weird brains. I love weird questions. What a lovely audience. I feel like there's no better audience than people who are nerdy about science and asking these kind of outlandish questions. And one that really stood out to me was from Chris from Ontario, who sent us a voice memo. Sent you and Julian a voice memo, and then I kind of stole it for myself because I was like, this sounds fun. It's a little bit of chemistry, a little bit of earth science, a little bit of animal biology, all fun things. And I haven't gotten a chance to talk about the science of fireworks in a bit. Ooh. So I was eager to dig in and learn some weird things about them.
All right. Let's play the clip.
Hey, Julian. Hey, Trace.
And Ceri.
My name is Chris, and I live in Ontario. Here's my question. What would happen if fireworks were a naturally occurring weather pattern? I was watching a fireworks show with my partner when the thought popped into my head. What if this could happen without human intervention? For science sake, feel free to pick a different weather pattern to substitute or supplement with fireworks. What impact would it have on the climate? What cool evolutionary adaptations might animals have related to firework weather? And most importantly, would that solve anything? Cheers.
Would that solve anything? The best. Thank you. Wow. Do you recognize would that solve anything, Ceri? That was a question we got a while back.
Oh, no, I don't. I'm not a real tape head.
Wow.
Unfortunately. Yeah, I'm sorry you had to find out this way, Trace.
No, that's okay. I never assume anyone listens or watches anything that I make, including my mother. Sometimes I'm like, Mom, I made this thing. And she's like, you did? And I'm like, yeah, I did. Not that makes my mom bad. I do too many things, mostly. So a while back, we got a question from somebody who asked about filling the Grand Canyon with seawater. And their question was literally, what if you did that? Would that solve anything? And we were just like, what? Just anything at all?
Uh-huh.
And so we really fixated on that phrase. Can that solve anything? Would that solve anything?
Would that solve anything?
What do you think? So it's nice to see the audience is picking up on that as well. So, Ceri, what would happen if fireworks were a naturally occurring weather pattern, and would that solve anything?
Will that solve anything? Well, I think to start with the basics, I'm curious, as a science communicator for a while, how much do you know about fireworks, Trace? I feel like everyone has questions about fire and explosions and all kinds of, it's so ripe for getting people excited about science. Do you have a go-to explanation for how fire works?
I mean, I don't, actually. I used to work at a baseball park, and we saw so many fireworks that I just got really, no pun intended, burned out on them. Because I don't know if you know this about baseball. There are a lot of baseball games, like a lot every year. And when you work at a baseball park, you watch all of the home games. So I watched 85 baseball games in 3 months and then was like, I'm good. I'm good. And if the game was a Friday or a Saturday game, there were fireworks. So that's a lot of fireworks.
So fireworks lost the spectacle.
They really did. They really did. I think they're cool more from like a production standpoint now. Like I want to know, okay, so how did you get them to do this and trigger them in this way? And like, oh, neat. So this is a big one. How much does that cost? You know, more of a nerdy behind the scenes way. But in the documentary Mulan, she definitely like uses some fireworks to fight off the Huns or whatever, right? So that's kind of cool.
Yeah. So many uses for fireworks, for sure. And I guess what would it solve is if we had firework weather, we would all become less impressed as a species. Fireworks would no longer become special.
Yeah.
I think that's the answer to the end of the question is we all saw fireworks like a thunderstorm. We just ignore them probably because that's how we are.
There'd be some people that are like, oh, love firework storms. And other people would be like, another one? I'm so annoyed. I have places to be. It's loud. I'm trying to record a podcast.
100%. There would be people being like, I can't believe I can't believe fireworks are on the forecast. I'm trying to podcast here. I'm trying to stream here.
My baby's asleep. Oh.
Yeah, the fireworks. Which people already do on holidays, to be fair.
True. Yeah. Oh, the poor doggos.
Poor little doggos. But I guess to go back then to the chemistry of what's going on, that was what it was exciting to me too about the fireworks. And this is where I think you can get really, really into the weeds of chemistry, but I'm going to pull back and do the basic. Let's understand the ingredients because I don't quite understand where electrons are moving around.
Oh my. Okay. Wow. We're going to go all the way there. I'm excited.
We're going to mention electrons. We're going to mention them.
Okay, yeah, just honorable mention. Love it.
Yeah, an honorable mention of them. But fireworks, you can think of them as packages of stored chemical energy that gets released all at once. So that chemical energy gets converted into heat and sound and light and all the things that make fireworks spectacular or not so spectacular if you see them 85 times in 3 months.
Right, yeah.
And the main ingredients of them, the two main ingredients are a fuel and an oxidizer. Those are like the two chemical components. And simply speaking, the oxidizer steals electrons from the fuel. And that is what any sort of combustion reaction is. Right. Chemists don't get in my mentions. I know it's more complicated than that, but oxidizers steal electrons from the fuel.
Yeah, it's the fire triangle, right? You need a fuel, you need oxygen, and you need heat. And you make fire.
To ignite it, yeah.
Combustion, really.
Yeah, that's that Boy Scout knowledge.
Yeah, it is. Eagle Scout over here, what up?
Wow. I was never allowed to join. I could join Girl Scouts, but Boy Scouts always looked like you did so many cool projects.
We had a lot of fun. And and girls can join now too, which is awesome. The Girl Scouts aren't happy about it, but the Boy Scouts, or BSA Scouting, I think as it's known now, allows girls, which is awesome.
Incredible. I love that. All gender scouts learning about the fire triangle. And so you see this fire triangle appear when you're burning wood in a campfire. So the fuel in that case is the hydrocarbons in the wood. And the oxidizer is the oxygen in the air around you. And then you need a spark, some sort of heat to kick off that chemical reaction. And it produces some water vapor or water that gets vaporized. And then some gases like carbon dioxide and other particles that comes out in the smoke. That's like the sooty stuff that flies up in the air. But those combustion reactions are really slow, relatively speaking. You can watch them burn. The wood takes a while to burn when you build a campfire.
Okay.
And in a firework, the explosion is just amped up. It's like you take all that chemical energy and you release it all at once instead of slowly over time roasting a marshmallow.
Yeah.
And in many fireworks, the ingredients, that fuel and oxidizer, are all mixed up in black powder, also known as gunpowder.
Right, yeah.
And that's been the main fuel/oxidizer combination in a lot of fireworks throughout history. And the fuel piece of gunpowder is charcoal, which is made of carbon, and sulfur.
Yeah.
And then the oxidizer piece of gunpowder is a chemical called potassium nitrate, or sometimes we use perchlorate in it.
Yeah.
And part of that is because we need something that will react a lot faster than the oxygen gas in the air around us. And when you launch a firework up into the atmosphere, the oxygen there is a lot thinner. And so you can't rely on oxygen gas to be an oxidant when you're making a firework. You need something that is ready to steal a bunch of electrons and packed right there in the package.
Yeah. And the potassium nitrate does that for you?
Yeah.
Cool. When I worked at the museum, I feel like I mention this every dang episode. When I worked at the museum, we used black powder weapons, original ones from the 1870s and 80s, and we fired them every day. And you smell terrible when you do that. It is awful because you just smell like sulfur, and you like get dirty. And potassium nitrate, also known as saltpeter, and it's so smoky. Which now I think about it, it smells like fireworks. So that makes total sense.
And that's it. The gases that get released are those sulfur dioxide, nitrogen oxides, plus all those sooty particles that make up smoke. And so when fireworks explode in the atmosphere, if they're made with gunpowder as their launching tool or their exploding tool in the sky, like that, all that stuff is released into the atmosphere.
Cool.
And then there are other things you can add to fireworks to make all the fun shapes. So you can add shapes and colors. So there are chemicals called binders that help keep everything together, as well as accelerants or retardants that can increase or decrease the reaction rates in different ways. And so the way that you pack together the gunpowder with these other chemicals can make like a firework that does one big boom versus a firework, you know, those little streamer ones that kind of like crinkle out as they fall.
Like a willow tree. Oh, so pretty, sparkly. And they probably add things, you know, iron oxides and stuff that makes it sparkle or whatever because it burns more slowly or something. Yeah.
A lot of metals or metal salts are what give all these fireworks the color. And so based on what metals you choose, that can either, most of them give the color by luminescence, which I'm going to honorable mention electrons again, but the electrons in those metals get excited. And then when they relax again, they release a photon of a specific color. That's like the simplest way of explaining it.
Yeah.
And they get excited just from the energy of that explosion, that heat and whatnot. The electrons get excited and fall. But some fireworks also glow colors because of incandescence, which is slightly different. I learned, and I don't know if I'll explain this quite right, but heat is basically the wiggling of molecules, and sometimes that heat energy gets released as electromagnetic radiation, and that is incandescence. And so it starts out, there are some wiggles converted into electromagnetic radiation, it starts out in the infrared, and then it starts going through the color spectrum. It goes like red, then orange, then yellow, and to that bright white light.
Yeah. Like a light bulb, incandescent light bulbs. Yeah,
like an incandescent light bulb. Exactly. So you can have two forms of color coming out of your fireworks, luminescent color and incandescent color.
That's neat. Today I learned. That's cool.
Yeah.
Fun. Do you have a favorite firework color?
Ooh, I love a green firework.
You know, I love a green firework too.
I don't know why. It's just
I don't know
so
either.
Incredible.
You don't see them as often. I don't know why that is. I wonder if it's because there's blue. Maybe blue is harder to make or something. I don't know. I really like the fireworks that are green, but also the ones that look like, I call them ADHD fireworks. The ones that like, they pop and then there's like a bunch of bright little dots and then they kind of scatter in all different directions. And I'm like, oh yeah, that's the want to go ride bikes firework. It's like firework. Oh, I got distracted. Woohoo! Like,
when they do the curly cues off in the distance.
Oh, I like those too. Those are fun. Yeah.
100%.
Maybe I am into fireworks.
You're into the idea of fireworks, I think. It sounds like.
Reignited it.
Ooh. There we go. All good science communicators. Hopefully everyone is like, man, I really got to see a firework now after this. But Chris's question, to be clear.
Yeah.
Chris, I hear you. You were not asking what is a firework. That's a basic question.
Yeah.
You were asking what would happen if somehow fireworks were a naturally occurring weather pattern. So my next step in this journey of discovery was looking at what weather exists or what creatures exist that could maybe replicate a firework in nature.
Cool.
A couple things popped immediately to my mind, but I don't know, Trace, if there's anything that you've seen. I know you do some earth science, stargazing, things like that, that reminds you of fireworks in any way.
Lightning bugs, fireflies, definitely. Chemical reactions in their little butts, thorax or whatever. Yeah. Other than that, we talked about the bombardier beetle recently.
I love the bombardier beetle, yeah.
Which is pretty cool. Not really a firework, but, don't get sprayed. No, thank you.
Yeah.
Other than that, I don't know.
Well, both of those were on my list, too. Fireflies are, you can sometimes see swarms of fireflies, and their chemistry is weird, like you said. Apparently, a lot of glowing creatures use this protein called luciferin and an enzyme called luciferase that oxidizes luciferin. So again, it's a losing electron reaction, like fire, kind of, but in the same cousin family, I guess, of the chemical reactions that do fire.
Yeah.
And as luciferin is transformed into a different molecule, it releases photons of light, and that's the glow that you see in fireflies.
Cool.
So theoretically, if you had a swarm of mating fireflies or something, could be natural firework.
Yeah.
Bombardier beetles, I think they're usually pretty solo creatures. But if you get a bunch of them and throw them up in the air, and they're all freaking out, they're all popping with their hydroquinone butts.
Yeah.
You got heat, you got sound.
Yeah. Yeah.
Maybe not as much color, but
no.
Kind of like a firework.
Yeah, cool.
Kind of like firework.
Kind of like fireworks.
The other bugs, they're species of exploding ants and termites. They're social insects that use explosions as a sort of defense. Sometimes they sacrifice themselves for the larger colony. But again, those aren't as fireworky. They're not really colored. They just fill their glands with fluid and then kind of, it's more water balloon
more
than
bursty.
Firework. Yeah.
Yeah. Like if you watch the Dune movies with Denis Villeneuve, they had the Giddy Prime had the bursty, gooey, fireworky things.
Yeah. But more goopy. Yeah, goopy than fireworky. But when you're getting into the earth science piece, there are two kind of phenomena that feel fireworky, maybe aren't as common as weather, but the aurora borealis, I feel it brings similar feelings as the firework.
Like a chill firework.
Yeah. Yes. Yeah. If normal fireworks are too frenetic for you, if you don't like the sound, you just lay out a blanket, watch the aurora come on through. And again, it comes back to electrons moving around. And that's what I think is so beautiful about chemistry and physics and all this science, is that if you go down to an atomic level, different compounds, different atoms and molecules are interacting with each other, but you can explain a lot of the things like colored flashing lights with similar principles.
Science is so cool.
Yeah.
Like if fireworks are like John Philip Sousa, the band master, and then
Oompa.
Yeah, the aurora is what, like Miles Davis.
Yeah. They're all music for your eyeballs, but
music
just
for your
totally
eyeballs.
different vibes.
Yeah.
So the aurora borealis happens when solar storms emit charged particles and electromagnetic radiation, which then interact with the Earth's magnetic field, sometimes transferring that energy or getting captured into the Earth's magnetic field, using very, very loose terms. And then the electrons in the Earth's magnetosphere collide with the atoms and molecules in the upper atmosphere, which then leads to that luminescence, kind of like a firework. So instead of the energy coming from gunpowder exploding, it's just coming from our sun instead.
Yeah.
And exciting the molecules that are already existing in the atmosphere, as opposed to ones that we pack in a firework that we launch in the air.
Cool.
And then the other thing that came to mind that's maybe a little bit more crash, boom, bang is volcanic lightning. Have you heard of volcanic lightning, Trace?
Volcanic lightning is so cool.
Yeah.
It's like, I mean, this is maybe a little too close, but if we're sticking with our musical analogy, volcano lightning is freaking metal.
Yeah.
Right? Like, it's just metal.
Metallica coming in.
Yeah. Like, you can't, it's amazing.
Yeah. So you get the boom of the volcano erupting, and then this time the electrons are moving because of friction rather than stored chemical energy. So as the ash particles in the eruption collide with each other and rub against each other, then those atoms are swapping electrons so that in the ash cloud, there's like a positively charged area and a negatively charged areas that build up. And eventually they need to discharge. Like the universe doesn't like imbalance.
No.
We like an equilibrium. We like to equalize things in general. So when finally the charge builds up enough, basically the electrons start jumping or discharging, and that effect of discharge of the electrons flowing back and re-equilibriuming.
Perfect. Nailed it.
That's a word. Then that's lightning. That's the lightning you see, and it occurs pretty frequently. I feel like now more than ever, now that we have cell phones, now that we have these documentations and people are viewing volcanic eruptions, we have all these really great photos and videos of volcanic lightning being in the clouds. And it's no wonder, honestly, that so many old systems of like religion and spirituality revolved around volcanoes and storms and whatnot. Because you look at volcanic lightning and you're like, that's incredible. That is powers beyond my comprehension. I'm going to run.
It's like epic.
And I better not make that guy mad.
Have you ever seen a volcano erupt? I have once.
I have not.
I was in Guatemala for a wedding, and I was walking back to the hotel through Antigua, and there's a volcano called El Fuego, and it was just, there's this like puffing off in the distance, and I was just like, that is wild that it's just happening right there. Then I went to the Volcano National Park in Hawaii, and it was right after it had erupted and like destroyed a bunch of Hawaii. So it was not erupting at that time. But like, you know, volcanoes are so cool. So is volcano lightning really just like static electricity then, I guess we could say, right?
It's just
the atoms pushing against each other and building up like a charge and then discharging it somewhere where it can find ground.
I think so. I need to learn more about electricity. I feel like it is a weak spot for me as a science communicator, but it sounds like static electricity to me. A lot of rubbing, a lot of friction, and then...
I mean, lightning in general is basically the same idea, I think. So cool. That's really neat. Those definitely are all fireworky for sure. For sure.
And so I imagine if firework weather existed, it would be something to that effect. It would be smoky. It feels like a special occasion kind of weather in the way that there would have to be very unique atmospheric phenomena. Because, as you mentioned, Trace, if it happened too often, it'd be boring. And that defies the logic of fireworks. They got to be special. So it's got to be a once in a while weather phenomenon, I think. Like a volcano erupting so that you can have the majesty of that. Or you can go to, have you heard of that? I forget what that Venezuelan lake that has lightning storms most of the days of the year, or like a vast majority of the year.
I'm Googling it,
Catatumbo
lightning.
Yeah.
What is Catatumbo lightning? Lake Maracaibo.
Yeah, Lake Maracaibo in Venezuela. But it's like over half the year. I guess 140 to 160 nights a year in the article that I'm reading right now.
Whoa.
Where lightning is just flashing constantly. And that sounds incredible and cool. And imagining like maybe there's one spot in the world where firework weather is like this.
Oh, yeah, that's like the thing. It's a weather phenomenon. It's
a weather phenomenon that you go to a place. And maybe this is it. Maybe this is the firework weather that you were looking for, Chris. You can go to
Venezuela.
Go to Venezuela. And watch your lightning.
Yeah.
What is lightning but nature's fireworks?
True.
Maybe. So when we are researching fireworks nowadays, when scientists are researching fireworks, we are mostly looking into what the effect of launching them are on us and our health, because they are
environmental impacts.
Environmental impacts, exactly. They're a human invention. As you described, Trace, it doesn't always smell good to like have an old musket when you're working at a museum, or some people really like the smell of a campfire, but maybe not all the time. And if you live next to a baseball stadium that launches gunpowder fireworks all the time, then what are the effects of the people who live around that?
Yeah.
And in general, we think the effects aren't great.
Oh.
The smoke can lead to asthma or asthma attacks in people who are predisposed to it. The colors that are caused by metals burning up, that can release metal particles into the atmosphere or around you that aren't necessarily needed there.
Yeah.
So sometimes, like, all of our bodies need some amount of metal. Like, for example, the hemoglobin in your blood needs iron in order to bind oxygen, in order to make sure that we can breathe, that our cells can survive. But there are some metals that our body doesn't incorporate as much. So strontium is the red in fireworks, or barium produces the greens, or copper produces the blues, and all these things. And some amount is okay, but then once you start sprinkling extra and extra from fireworks exploding, then I think it's usually not as great. So I'd imagine if firework weather were a thing in a one-to-one analogy, if they were just gunpowder exploding, then there would be people probably with more respiratory illnesses in that area, or adaptations to defend against those respiratory illnesses. Maybe other things in their body to either incorporate or utilize or filter out those metals. And whether that's the people or the animals or the plants or the ecosystems around, I would imagine that there would be some sort of adaptation around that.
Right. I was wondering if maybe like the particles released, like if it was a firework, like a proper firework, right? You're releasing, it's loud. That means animals are going to be affected.
Yeah.
There's soot. So that would mean particles both in the atmosphere, but also potentially raining down on whatever, trees or other things. You're breathing them in.
Yeah.
I didn't think about the metal particles though. Like then that's like a whole other level.
It's a whole other kind of compound. And what's weird and cool is that we know that animals like insects already integrate some kinds of metals into their claws or their mandibles or their exoskeletons. And that's how they get so sturdy. So we've seen evidence of like a beetle integrating zinc or magnesium, or a wasp into its stinger to fortify it and make sure that it's strong enough to penetrate wood or another insect or something, like whatever they need it to. Because metals are really sturdy. And there are some animals, like one of my favorite weird animal, I have so many weird animal facts that I love, but there's a deep sea scalyfoot snail that is super rare that incorporates iron into its foot. It lives by deep sea vents and is just a little armored snail.
What?
It is so cool looking.
That is so cool.
Yeah.
Yeah, you defend yourself, little snail pal.
That's it. It just lives by these deep sea vents where there's a ton of iron. And so it just figured out how to have a little armor coating. It's like a Pokemon.
Yeah, that's cool. Like a Pokemon?
Yeah. Just
That's
a little
funny.
guy.
That's cool.
So I can imagine the optimistic version of that reality is that we would have animals like these insects, just everything would have armor. Everything would look really cool.
It would have evolved to like pick up all this metal that somehow gotten into the atmosphere and then popped its way back down.
Yeah, because like presuming that this is a natural weather phenomenon, like the water cycle, we'd have a firework cycle or a metal cycle or something like that.
What?
And so there has to be something that's getting the metals up into the air in the first place. And as they're raining back down, then we might have a legion of insects or snails or even probably not larger creatures, but who knows? We can imagine whatever we want.
Yeah,
who
true.
then incorporate those metals into their bodies for some reason, probably into the hard bits, the claws, the teeth, things like that.
Right.
And everyone's just a little bit more metal than before.
Yeah, just a little bit more metal. Yeah.
Yeah. And what would that solve? Ooh.
I don't... there's been studies that people who listen to metal are usually like have lower levels of anxieties. I'm pretty sure, if I'm remembering that correctly. Maybe it's just my friends who listen to metal who tell me that. But so maybe we'd all be just a little more relaxed because we just get it out, just because of all the metal.
Yeah.
Well, we'd have to listen to metal, not be metal.
Not be part of metal. Well, we'd have a whole subset of studies about what if you listen to metal while also being engulfed in metal.
A little bit metal.
Yeah.
I wonder if the metals would get up there based on, like volcanic eruptions or something like in order for them to be a natural occurring phenomenon, as you say, right, there'd have to be this metal or like, a saltpeter cycle or something. And in order to do that, you would need to get stuff that's minerals basically into the atmosphere. Mm-hmm. So there'd be a type of volcano that's like more of a mix between a volcano and a geyser, where it's like a little more gaseous, but it's like aerosoled minerals almost. Mm-hmm. It'd be kind of cool.
And that is kind of how the last thing that I looked into for this was like, what is the actual thing that is most like firework weather?
Yeah.
And it's Disney. It's the Disney Corporation.
Yeah.
Where they really regularly, like nightly in the hit seasons. Sometimes multiple times. Yeah. As you used to live in California.
Yeah, Disneyland. Well, luckily far enough away I didn't have to deal with it. But I knew people who lived in Anaheim and they're like, hey, fireworks all the time. Just all the time.
They're just there. And it turns out that what's interesting is Disney partnered with the Los Alamos National Laboratory, which is the same one that works on like nuclear weapons or the atomic bomb, to develop more environmentally friendly fireworks starting in the 1990s and 2000s, because they were launching so many and because the Anaheim community was like, hey, there's a lot of soot in the atmosphere. I'm getting these heavy metals. I'm not incorporating them in my body. I don't feel cooler. I don't feel more relaxed. Can you do something about that?
Yeah.
The most magical place on Earth.
Our AQI is real bad.
Yeah.
Yeah.
And so instead of using launchers with gunpowder in them, they use air pressure to launch a lot of their fireworks now.
Yeah.
And instead of using gunpowder to explode them in the sky, they're researching nitrogen-based compounds. So derivatives of tetrazoles and tetrazenes, which are both ring-shaped nitrogen molecules. And because our atmosphere is so much nitrogen in it, this reduces the amount of smoke, it reduces the amount of air pollution, it reduces the amount of gases that could potentially like react in different ways in the atmosphere. And there's a whole push, it turns out, of chemists who are into fireworks, who are into the chemistry of explosions, who are researching ways to make it greener.
Cool.
And so we've been talking about gunpowder, and I feel like my canonical idea of firework weather would involve the soot and the smoke and the volcanic eruptions. But maybe there's a chill form of firework weather where it's still got the metals. I don't think you can have the colors without the metals, but different versions of exploding compounds in the sky.
We just haven't discovered it yet.
Yeah.
Cool. Whoa, neat. Well, thanks for looking into that. That's awesome. And thanks for asking your question, Chris.
Yeah.
That was a great question.
Thanks, Chris.
If I knew somewhere in the world, I don't know, South Africa or something had firework weather, that would be in the like things to see before you die book, right? Mm-hmm. Definitely.
100%. I feel like Lake Maracaibo, that Catatumbo lightning, is already on my bucket list of...
Yeah.
And
just going.
Just going.
Man.
Looking at all that lightning.
Right? Also, visit South America. It's awesome.
Mm-hmm.
It's great. Anyway, let's take a quick break and come back, and I'll answer a question about ghosts. Julian, give me your best dinosaur roar.
Oh, God, an asteroid! It's horrible!
Wow, that was not where I expected that to go. We're popping in before the show to tell you about I Know Dino. It's a dinosaur podcast.
We think of those dinosaurs being this thing that's been dead for tens of millions of years. Even so, studying dinosaurs can still teach us stuff that is relevant to the world today.
Yeah, like climate models to help us understand global warming.
Migration patterns of dinosaur lineages, they tell us about Earth's changing continents.
We can also study dinosaur diets, what plants lived then, and maybe what animals and how they interact.
And, this is super cool, many dinosaur injuries, paleopathologies, they're the first known occurrences of diseases.
And they talk about all this kind of stuff on I Know Dino. It comes out every week with new dinosaur stories that you're not going to hear anywhere else. Like, I hadn't heard of a lot of these, which is pretty cool.
You can find I Know Dino on Apple Podcasts, Spotify, wherever podcasts are. And if you found us, you can probably find them. Go check them out.
Welcome back from the break. And I thought of one more thing, which is the noise aspect of fireworks while I was thinking about, like,
ooh. Yeah.
Would we get used to that noise? We were talking before the call about parenting strategies and how maybe if you should talk about it. I'm not a parent. I'm talking about this as though I have a kid. I have a cat behind me and she sleeps through everything.
Yeah.
But we might get accustomed to the noise of firework weather too.
Yeah, yeah.
If it came frequently enough.
Yeah, we were talking about how my kid sleeps through the night, and as you said, n equals 1, and I was like, yeah, we were loud when the kid was born on purpose. Like the kid would sleep, Raphael would sleep on the couch in the living room, and we would run the dishwasher or just be loud. And part of that was so that he would know that the environment is not always quiet. Mm-hmm. And it seemed to work. I don't know.
So maybe with firework weather, we would just get used to the booms and bang. Like right now, it happens too infrequently that whenever we hear a firework, we're like, whoa, is that? In the same way of a thunderstorm. Yeah. But maybe we get used to it.
Maybe we would. That'd be cool. I mean, maybe it'd be good for us and also bad. Hopefully the doggos would.
Most importantly, the little guy.
I guess if they evolved with it, they would.
That's true. Yeah. If it was weather. But even then, they get scared of thunderstorms, and they evolved with those as wolves. So, and with that, I am going to throw it over to Trace because I'm excited to learn about ghosts. Exactly in that tone of voice.
Yeah. I mean, I can't say it that way every time because I'm going to say ghosts so many times now. But yes, I have a question this week that was sent in by, I think his name's Julian Huguet.
Oh.
It was sent by Julian. Julian typed it in. I figured since he wasn't here, we should answer one of his questions that he put in when we first started the podcast. And he wrote, if ghosts were real, how fast do you think they would move? The speed of light or faster? And I thought that was interesting.
I love his weird brain.
He's
still here. I know I said that about my question. I love the weird brains of these podcasts.
Yeah, for sure. So the premise here, of course, is that ghosts are real. And I think that was the thing I struggled most with when writing this answer was remembering, no, Trace, ghosts are real. We're not debunking ghosts. We're just talking about ghosts.
We're starting in an alternate reality where ghosts are real. We're in Scooby-Doo.
Where there's ghosts and firework weather. This is a weird planet. Mm-hmm. So in 2021, there was a poll of 1,000 American adults. And any guesses the percentage of people who believe that there are ghosts?
Oh, like 20%?
20% said they personally had experienced ghosts. 41% believed in ghosts. I know.
That's wild.
I mean, it's not bad or anything. It's just like more than I thought. I thought it'd be, like a quarter or something. But if you think about 20%, that means 67 million people have personally experienced ghosts, or so they think. Ceri, have you ever experienced ghosts?
I've not. Now I'm thinking, I am a easily frightened person, I would say. So a lot of bumps in the night. I'm always like, what is that? Is it an animal? Is it something else? Is there someone in my backyard? I definitely catastrophize in that way, where it's like, is someone coming to murder me? Why would someone be coming to murder me? But never in my mind would I say, oh, there's just a ghost in my backyard. But I can see how that would be really comforting instead of...
It would be more comforting, yeah.
Going down my little spiral.
I do love, though. I really love your brain because you're like, someone's coming to murder me. And your first thought isn't, what do I do? It's, why would they be coming to murder me? You're like, let me analyze this. It's interesting.
Mm-hmm. Well, there has to be a reason.
I know. I love that. I love it. Okay. So I used to live in a haunted house when I lived on the island where I worked at the fort. The building was a historic building, and allegedly there was a little kid with a red ball who lived in the building who people had seen, and I'm sure it was just something they made up to tell the new employees, but it was very creepy. The second floor of the building, you go up the stairs, it was called the Mission House, and it used to be, it was a school, it was a hospital, it was a school for like native children and like indigenous people children, and the white people there did not take very good care of those children, so there were a lot of kids who died in that building, and so people were like, oh no, there's ghosts in the building. Anyway, I definitely experienced creepy feelings, never saw anything, but creepy feelings, and that's important. I think a lot of people have experienced those feelings and they don't understand them, and so it's much easier to attribute it to a ghost or something else, something supernatural or paranormal, than it is to try and understand that It's something else. And we're going to get to that. I am going to debunk ghosts a little bit. But at the end, this is a world now where ghosts are real, though. Okay? Ghosts are real. So, okay, Trace, ghosts are real. Just keep telling yourself ghosts are real. They're not real, but in this world, but in Firework Weatherland, they're real.
They're real.
So knowing that, what do we know about ghosts? What makes a ghost, right? It glows. Mm-hmm. You can kind of see through it. So it's like an apparition.
You can go through walls or objects.
Yeah. Go through walls, but not always. Because sometimes they'll like push
rules.
Stuff like a cat, they'll like push stuff off a shelf. Or like flip on a light. Crinkle
some chains. Whatever.
Chains.
Yeah, bum. Things like that.
Tell old rich guys that they should probably be less crappy. There's all sorts of really good.
There's some time space manipulation going on with ghosts too. In Ghost World, the rules of physics are a little bit different. I think.
Definitely.
Yeah. And they're not tethered to the ground too, right?
Yeah, they float around.
And they float. That's the whole thing. They're hovering little creatures.
Yeah, they hover. The one that I was like, they make people feel cold. And I was like, this one is important. Mm-hmm. So I made a note of all these different things. And I started looking into all of these. So if ghosts were real, Julian wants to know how fast they would move, right?
Yeah.
How fast something moves is determined by how much energy it can either expend if it's moving itself or absorb if the energy is causing it to move, right? Almost exactly like you were just saying with the fireworks, it has to do with that energy exciting electrons, and then the electrons change orbitals and they move and then they fall back down and release a photon. It literally, I was like, oh, great, I don't have to explain this. So when we see things that are glowing, for example, or something that is an apparition in that it has absorbed light and is reflecting it back, right? Like a green thing is the light that is being reflected as green. Mm-hmm. It's absorbing all the other lights. And so if something is visible to us, it means that it's absorbing light. So photons have hit it and it is there. Something has absorbed or reflected or refracted or polarized or diffracted or scattered or transmitted. Well, transmitted is see-through. So done something to those photons. Reflected and scattered is bounced. Diffracted and refracted is bent. And transmitted is traveled through. And absorbed and polarized or excited and re-released. Those are all the things that photons can do. I looked it up, which I was like, okay, cool.
Amazing. And it sounds like in ghosts, they would do a little bit of everything, including going through, because they're that transparency sheen. They not only glow, but
they're mostly those first three. Like you can kind of see them, and then some of the transmitted as well, because maybe they're see-through here or there where you don't expect them to be. And then there's also the bumps and thumps and the cat pushes and the light switches and like picking stuff up or whatever. And to do that, they have to have mass. Or if you're being really nerdy, they have to be able to interact with the Higgs field.
Ooh, I know nothing about the Higgs. I know that the Higgs boson exists, but that's beyond me. I'm so excited to learn some ghost physics in Ghost World.
Julian is sitting on the edge of his seat and bouncing up and down right now just because he loves particle physics as much as I do. So particle physics, in very simple terms, describes the motion of the very small, and also basically all particles have something that they do. There's a purpose to them. So a photon is a light energy carrying an electron is a negative charge. There's an anti-electron though, and there's an antiproton, so it's not always just the charges. Mm-hmm. But the Higgs boson is a carrier particle, meaning it's basically what causes us to have mass. It's interacting with the Higgs field, and the Higgs field is what gives a particle mass. If you don't interact with the Higgs field, you don't have mass. And if you don't have mass, you can't move things around because you have to be able to physically interact with it. Mm-hmm. And so that I found very interesting, because if a ghost can interact with the world that we're in, it needs to likely interact with the Higgs field, which would mean it has mass. Mm-hmm. If it has mass, it means it's a thing. And a thing cannot travel the speed of light. But it can travel slower than the speed of light. Yeah. And, how fast can it go? Because what else do we know about ghosts? We know that from the movies, there are documentaries about ghosts, LOL. There's Ghostbusters, excellent documentary about ghosts. Beetlejuice, there's 2 now. They're all ghosts. Yeah. Sixth Sense, ghosts. one of my favorite movies as a kid, Peter Jackson's The Frighteners. If you haven't seen it and you like moderately scary but not really scary movies, it's quite good. It's more of a murdery movie, but ghosts are involved. And also, interestingly, most ghosts seem to be like white Victorian people, but that has more to do with our cultural stories than anything. And The Frighteners has like ghosts who are African American, which is awesome. And then there's like Lovecraft Country, the movie Ghosts, of course. I don't know. There's a lot of ghost stuff in our culture. So I guess that means ghosts can also maybe help make pottery, which would be cool.
Yeah, not only can they bump and do all the other things, they can have fine motor control.
Yeah. And also the having matter thing and not being able to travel the speed of light, right? E equals mc squared. You'd need an infinite amount of energy to push something with mass to the speed of light. Photons can go the speed of light because they don't have mass. They don't interact with the Higgs field. But if a ghost can move stuff, if it can interact with stuff, it must have mass. And so it can't go the speed of light. But how fast can it go? And then also we talked about ghosts. They can make people feel cold, which I thought was really interesting. Because what is cold? It's just the absence of heat. Really.
Yeah, temperature is so weird. I hate when you start thinking too much about temperature. It's like, well, do we have temperature receptors? What are we sensing when we're sensing it? We're sensing the movement of molecules, not like a quantity of thing that is heat.
Yeah. Heat is just moving from one place to another, and we're like, those molecules sure are excited.
Yeah.
That's pretty much it.
It's like, I want to go back to whatever Victorian era where we thought heat was a measurable, like, oh, you just are transferring heat energy to each other. We've got phlostagon or whatever they called it.
Oh, man.
We're going to pass it back and forth instead of our modern understanding of I'm sensing the vibration of molecules and saying burr.
Right. So if heat then moves from one place to another, that would, again, kind of give credence to the ghost having some kind of mass, because it would have to have molecules to absorb that heat. It would be able to sink the heat into that thing. Physicists have this term called phase change material. Water's a phase change material. It absorbs heat without rising in temperature while it's absorbing it, which I was like, wait a minute, what? Because isn't it getting hotter? Because eventually water will boil, right? But the example that I read here was ice. So you have water ice, regular old ice cube. You've got it on a stick. If you stick it into a campfire, what happens to the ice? It melts.
Oh, it melts.
Right?
Yeah.
But if you stick it in for just a little bit and it starts to melt and you pull it back out, it's still ice. And it's still cold, even though it's been in a fire.
Okay.
Because water doesn't change state all at once. It changes state over time. So it's the liquid is what is changed temperature. Just that bit of the water has changed temperature. The rest is still literally 0 Celsius or 32 Fahrenheit, even though it's in a fire, which is kind of wild to think about.
Yeah.
Heat's weird.
Heat is weird. And that's why you can put in, I don't know, something in an oven. It doesn't always cook evenly.
Yeah.
Or if you microwave something, that's heat also. You can still have a ice cold center of your pizza pocket, and then the outside is molten hot.
The worst. Yes. Yeah. And the outside is super duper hot, and you bite into it and you're like, hot, hot, hot. And then you wait a little bit and you bite into it again. Now it's normal temperature, but the inside is frozen, and you're just like, this is the worst day.
This is the worst dining experience of my life. Yeah.
I'm never coming here again. Sir, this is a Wendy's.
Yeah.
Please don't bring outside food from your own microwave to Wendy's.
And then complain to me about it, sir.
Please don't bring your microwave to the Wendy's to make your hot dog.
Sir, I make minimum wage. Please do not bring your microwave into the Wendy's. I cannot control what you do or do not do. I'm going to get my supervisor.
So, interestingly, on his podcast, Neil deGrasse Tyson, not the most amazing guy, but an interesting fella, he had Adam Savage on, famous Mythbuster man, and he talked about, Neil deGrasse Tyson did, aerogel, and said if ghosts were real, they would be made of aerogel. So here's a little clip. Take a watch. Can you describe kind of what it looks like for people that can't see it?
Yeah, of course. So aerogel, it is like this bluish, whitish, hazy substance. And what is so interesting, we've been talking about it being ghost-like, is that the edges where it meets the air around it look hazy almost.
Yeah.
Like my eyes can't quite focus on it. And you can see light passing through it. And the way that Adam Savage is holding it up, there is so little mass. It's so much air that he's moving his hand and it doesn't look like he's holding anything at all, even though you can very clearly see this like blurry blob in there.
Yeah, definitely. That's an awesome description. Yeah.
It does look like a ghost. I agree.
Isn't that crazy? When he puts it in his hand, does that look like a ghost?
That's insane. Yeah.
Right? It totally looks
fuzzy around the edges.
Yeah. Like what a ghost might look like. Mm-hmm. For sure.
I have always wanted to touch aerogel.
Me too. I was so jealous of Adam here. I was like, dang it, man. You're so cool touching aerogel. So he pulls out the aerogel. They touch it. We'll put part of the clip on Threads and put it out there so y'all can watch it in the audience. But Neil deGrasse Tyson says here that if ghosts existed, they would be made of aerogel. But aerogel is actually lots of different things. The other episode, we talked about the longest selfie stick, and I mentioned that there are a lot of different aluminums, 6607, 6608, There's a lot of different aerogels. They don't have cool numbers, but there are a lot of different ones. Do you know what an aerogel is? Have you seen this before?
Oh, I don't know if I know what it is actually made of.
Yeah, I'd heard of it, right? I'd heard of it as a thing, and I'd seen it as a concept, and I was like, I want to touch it. I don't know what it is, but I want to touch it.
Like a spacey material. I feel like I've read it in the context of NASA is using aerogels because it's really expensive to bring stuff up into space, and so if you have a really light foam-like material that's useful for insulation, it's useful to just bring stuff up.
Yes. 100% nailed it. So aerogel is exactly that. It's basically like a foam. It's a polymer. It's mostly air. Tyson says here, 99.9, maybe more. I've read, 95% all the way up to into the 99s. But it depends, again, on the type of aerogel. It's a polymer chain. And when it's made, they kind of spin it. And it's sort of like science cotton candy, kind of. But it's mostly air. And the aerogel itself is the molecules left behind. And I read, what does it feel like? It feels sort of like, according to one expert on aerogels, the aerogels like kind of website, essentially, says that it feels sort of like a styrofoam peanut. Or like the green brick that you put flowers in, like the potting bricks. It feels sort of like that. It's like kind of foamy and it's crumbly. Like if you squish it, it can be brittle. But some types of aerogels are flexible, some are hard, some are rubbery, but it's mostly air. It's like 95% air. And NASA wants to use them for spacecraft insulation. They want to use them because it can absorb a lot of heat and it can protect a lot of heat from leaving or entering the spacecraft, depending on what you want it to do. And silica aerogel is the very popular one you see on TV and on YouTube. It's transparent-ish. It looks blue. And it looks blue in case you're really nerdy because of Rayleigh scattering, which is the same thing that makes the sky look blue. It's just scattering those small little bits of light. And so this still fits with, though, ghosts being a thing, right? It's a matter. It's a matter-based thing. And so I did some math, and I said, let's say we had the least dense aerogel. So let's take Dr. Tyson's premise here and say that a ghost is made of aerographene or graphene aerogel. It's the lightest version of an aerogel. It's 160 grams, get this, per cubic meter.
Oh my gosh.
So to put that in perspective, that's about the size of a large hot tub or 17 beer kegs that weigh as much as a hockey puck or like a hamster.
Yeah, you'd look so strong holding it up.
Imagine, you have like this weird ghostly hot tub that you're holding, and you're holding it in one hand, and it's like you're holding a hamster, but it's gigantic. It probably would have mostly with problems with wind, but it's an incredibly light material. And even still, what do we say ghosts do? They float. This would not float. It's 3 times denser than air. So it would still sink. So I do think that Tyson nailed it with what ghosts would look like, right? So I think we have some kind of concept of what if ghosts were real, what they might look like. They might be made of some kind of aerogel-esque thing that we just don't understand. Because paranormal and supernatural imply that we can't study it. We can't understand it. It's outside of nature. It's outside of the norm. But I'm not going to take that view. This is when we're going to start to get into the debunking ghosts thing, but not entirely. We're still talking about ghosts and how fast they can move. So if this aerogel or graphene aerogel was what ghosts were made of, or some version of that, still you could find a version of it that would be lighter than air. There's a carbon aerogel. It was published in an open access journal, Scientific Reports, in 2021. And it was this incredible aerogel that absorbs heat from light. They would turn on a lamp in the room with the aerogel. It would absorb the photons and levitate. Yeah.
That's a ghost, baby.
And then they would turn the lamp off and it would come back down to the ground, which is awesome. I was like, okay, so it might have aerogel-esque properties, which is like a polymer with no liquid in it. They've essentially evaporated the liquid from the polymer, and all that's left is the polymer molecule chain, which is why it's mostly empty space.
So what I'm hearing is ghosts are dry.
They're very dry.
Ghostbusters, the documentary, and
They're very
Slimer
wet.
being goopy, they're very wet ghosts. But scientifically speaking, ghosts need to be dry.
They'd be dry. Interesting,
so
right?
dry. Yeah.
Because otherwise, how would they float? They'd have to be pulling energy from somewhere. Like, okay, I did look up. Just first out of the gate, I was like, okay, Ghostbusters, most famous ghost in Ghostbusters, Slimer.
Yeah.
Most famous ghost in Ghostbusters, has a fandom Wikipedia page. He moves 45 miles an hour, 72 kilometers an hour. That answers Julian's question.
There
I was
we
like,
go.
this
Easy.
is too boring. This is too boring an answer. It took me 2 seconds to find this out. Where does Slimer get his energy? Well, Slimer eats a lot, so probably from that. But that means that Slimer isn't really a ghost. Like, he's just a physical thing.
It's just a big, wet guy.
He's a big wet guy.
Not a ghost at all by any of these definitions.
Right. So, the thing also that you mentioned is that ghosts move through walls, and that confounds them being matter.
Yeah.
Because most matter doesn't move through walls, except for one kind of matter, neutrinos.
Oh.
Neutrinos move through walls, in fact, move through all of us all the time, trillions of them, like all the time, every second. Aerogels, though, are polymers. They can't pass through walls. And so that kind of confounds my theory of them being made of aerogels because they can move through things. Unless, of course, we're saying, you know, some of these things are fanciful and some of these things are real. Like if a ghost can't move through a wall, cool, the aerogel explains it. If a ghost can move through a wall now, the aerogel doesn't really work. And we didn't think, by the way, that neutrinos had mass for like a long time, till like the 1990s, when the Super Kamiokande Observatory in Japan found that they had mass. It's just like 1 million times lighter than an electron, which is
Wow.
really, really light. They don't interact with the Higgs field. And interestingly, do you know why it's so cool?
No.
Because they are left-handed.
And the Higgs field is right-handed?
Yeah, so in biology, right, there's chiral molecules, and they're twisting to the left or to the right. Because neutrinos are left-handed, or chiral, they don't interact with the Higgs field. So they think, they haven't discovered it yet, that there's a right-handed neutrino that would be like super heavy in comparison, still quite light, but super heavy, that would like be the partner of the neutrino, because all particles have a partner. So what if ghosts are somehow non-Higgs interacting exotic matter?
So I'm hearing ghosts are dry and left-handed.
Yeah. And somehow interacting with, I don't know, heavy neutrinos or something. Yeah, I don't know. Because then they could go the speed of light. Not faster than, because nothing goes faster than that we know of. But they could go the speed of light, which would be cool. Some people think that ghosts are pure energy. That's something we didn't talk about, but like maybe they're just an energy being. And this guy named John Kachuba, in his book Ghost Hunters, which came out in 2007, uses this quote from Einstein to be like, oh, they're just energy. And it's used a lot, and I bring it up because I don't like when people use science words to talk about non-science concepts. And he wrote, quote, Einstein proved that all the energy of the universe is constant and that it can neither be created nor destroyed. So what happens to energy when we die? If it cannot be destroyed, it must be transformed into another form of energy. What is that new energy? Could we call that a ghost? No.
That's not how that works.
That's not how any of that works.
That's not how decomposition works.
Yeah, the energy is still there. It's chemical energy. It's just in the bonds of the stuff in your body.
Yeah.
It's not like the Matrix where there's like electricity coursing through our body. It's chemical. It's all sodium channels and ions and things. But I understand where they're coming from. I'm just bringing it up to be like, no, that's not how it works.
Doesn't. Yeah. Yes. I can understand that is where philosophy meets science, right? Like, what is consciousness?
Yeah.
Beyond the electrical signals in our brain. And we don't know. But if we're using our current understanding of energy, it's sodium channels in our neurons. Just,
right. Yeah.
I don't know. Potential gradients and electricity in that way that when we die becomes goo and reabsorbs into the earth or whatever we choose to do with our bodies.
Yeah. Shoot them into space and they'll rain down through an aurora.
Yeah.
That'd be cool.
Put them in a firework and...
Yeah, that'd be neat. Probably against many laws, but that'd be cool.
Cool. Maybe a little gross, depending on how fresh you are, but...
Maybe a little gross. So to return to Julian's question, kind of wrap this up. If ghosts existed, they would be limited by their mass, likely, and any energy that they could absorb. Light energy is abundant, but doesn't carry a lot of energy. And I did do the math that if you had a room, like a dark room at 1 lux, there would still be a lot of photons, like a lot of photons, like 10 to the 17th, 2 times 10 to the 17th photons, which is a lot. And if you were going to move an aerogel of 160 grams, about the size of a person, so like say a child-sized ghost, and you wanted to move 1 meter, or like at about 10 centimeters per second, so like a slow-moving ghost, there'd be more than enough photons. If they could absorb all the photons in the room, they might have enough energy to move 1 meter, which would be kind of cool. About 10 centimeters every second. But you'd need like a really exotic material that could literally absorb all the photons in a room in order to move itself 10 centimeters and somehow do it consciously, which would be interesting, you know?
That's a little bit less fun than all the ghosts of Ghostbusters.
Yeah, true. Yes. And they move really fast in Ghostbusters. Where are they getting that energy?
Where are they getting it?
Where are they? So all these science words, I want to be very clear. I'm not saying ghosts are real. I'm not trying to prove they're real. I'm kind of trying to do the opposite. And Carl Sagan wrote, extraordinary claims require extraordinary evidence. And the Occam's razor of ghosts is that we have no examples of them. Like everyone has a cell phone in their pocket. Where are all the photos and videos of ghosts? All of them. There would be, like you just mentioned about volcanic lightning. They used to be something that, this happens rarely. We rarely get a picture of it. Now we have lots of examples of it. And I would say volcanic eruptions with lightning, probably less common than ghosts of the billions and billions and billions of dead people, assuming there are any. So what people have typically said are probably ghosts are things like sleep paralysis. People feel like they wake up and they feel a presence in their room. There's a ghost or a demon or an alien. Stephen Hupp, clinical psychologist and professor, writes about this. Someone is sitting on their chest, and sleep paralysis is just unbalanced brain hormones. You've woken up and your consciousness is there, but you have this hormone that's paralyzed your body so that you don't act out your dreams when you're asleep, and it hasn't stopped being made yet. Authors of Ghostly Encounters, The Haunting of Everyday Life, which was released in 2016, interviewed lots of people with supposed ghost encounters, and there were no consistent experiences. There was no like, this is a ghost, and here is the thing that makes it a ghost. In fact, they wrote, quote, many participants were not sure that they had encountered a ghost and remained uncertain that phenomena like that were even possible, simply because they did not see something that approximated the conventional image of a ghost. But they did feel an uncanny, inexplicable, extraordinary, mysterious, or eerie thing. The brain wants to make things out of things that aren't there. A study in Frontiers of Young Minds in 2022 looked at the amygdala and perception, and when afraid, other parts of the brain are essentially shut down or like recruited to help assuage the fear condition. And so we try to see patterns where there might not be, and shadows, or, we wake up in the middle of the night. We evolved to be in the environment, like a wild environment. So our brain is hijacked by the amygdala, and we're like, where's the predator? Where is it? It's here somewhere. Mm-hmm. And in the study, they literally showed participants television static, which, if you are young enough that you don't remember that, just like go to YouTube and you can find it. It's just random noise. Mm-hmm. And they put faces in the static. And sometimes it was prominent, sometimes it was subtle, and sometimes there weren't any faces at all. And surveys of the participants, people who were likely to say they'd seen ghosts, were also likely to see faces in the static when there weren't any, which is just classic pareidolia, which is like seeing faces in things like the face on Mars and stuff. Yeah. There's also a study in current biology where they used a robot to copy movements. This one's really cool. So they blindfold you, Ceri. Then they have you touch a robot and move your finger around.
Okay.
Then they have a robot behind you that gently mimics your exact movement.
Ooh.
Yeah. Isn't that creepy?
Uh-huh.
So if you poked it, it would feel like you're poking yourself. Mm-hmm. So then they did the experiment again, but the robot behind them moved just a little bit slower than they did, but it still copied their movement.
Yeah.
And at that point, people said that they felt like something else was in the room with them. Not the robot, the researchers, or them, but like another presence, because they were being touched, but they weren't being touched exactly like it was just, their brain was like, I don't understand what's happening. There's someone else here.
That happens to me sometimes, not with a robot behind me, but if I wake up, because I'm like I would say a restless sleeper a little bit. I get tangled up in a blanket or whatnot. If for some reason I have contorted myself in a way that like my hand is touching my arm, and when I wake up, I'm like, oh, something's touching me, but it's myself. And I just haven't, like, my brain hasn't kicked on to know where all my limbs are. Oh, and that's a really startling thing. But I feel like that's the same thing, basically, of just what your perception is and how it makes sense with the reality that your brain is used to. Yeah.
I bet you there was some amygdala like interaction there too, where you're like, I'm scared. That's someone else's arm, Yeah. There's this classic science psychology experiment where they put your arm under a table and they put a fake arm on the table. Mm-hmm. And they interact with your arm under the table, like the researcher does, and on top of the table at the same time, the fake arm. So they like tickle it with a feather, and they're also tickling your real hand. Your brain has trouble discerning between the two, the fake hand or the real hand, even though you know it's fake.
Yeah.
And then they hit the hand with a hammer, and the participants react because they're like, you just hit my hand, but they know you didn't. And so it's just your brain has all of these things, these tricks that we tell ourselves. And you can also cause the feeling of that presence feeling in people. This is a pretty famous study that was done not that long ago where they put a magnetic field over the right temporoparietal region, or in the middle of the brain as well. And it made people feel like there were presences in the room, or it made them feel afraid or smell weird things. And they think that this explains why some people feel God in a room with them, or feel ghosts or spirits or whatever else, because it's literally just, they can turn it on over the brain and you feel like there's an angel in the room with you or something. And then turn it off and you don't feel like that anymore. And so it's just really fascinating stuff. But if all that's not enough, there's a Ghost Hunters show. It aired from 2004 to 2016. Had 11 seasons, 230 episodes, and 10 different specials. And how many ghosts did they capture in a show about capturing ghosts? None.
Yeah, that was going to be my guess. 0.
Ghosts. So, yeah. I'm not here to debunk ghosts, but I sort of had to.
You gotta, yeah. So we had to live in the reality of what is a ghost. And the science communicator in you had to say, Look. I'm not saying there could never be ghosts, but if there are, they live in nature, and we will eventually understand what they are if they are there at all. But yeah, magic. Aliens though. Aliens. I saw aliens once. I woke up in the middle of the night and I definitely saw aliens out my window. And aliens are real. They're just waiting on Mars for us in the lava tubes with their little firework weather.
Wow. Somebody asked us about aliens. We can talk about aliens for another hour. But that's it. Our episode's over. We did it. 2 questions.
Incredible. I loved it. It was great. Thank you, Julian, for your question and your spirit and for letting me replace you.
Oh, I don't think it's replacement. It's augmentation.
I am bionic Julian. That is what the headcanon is now. Yeah.
Well, thank you for coming on, Ceri. If people want to come find you and learn more about your science communication, where can they do that?
Yeah. So you can find me on the podcast SciShow Tangents. It's everywhere you find your podcast at SciShow Tangents.
Love it.
Where we play science games, basically. So instead of taking one question or 2 questions and unpacking it for the whole episode, each episode is about a topic like mucus or birds or seeds. And me and my friends Hank Green and Sam Schultz, we play trivia games and try to stump each other or impress each other with facts. And Trace was on one of our early episodes.
It was
also
so fun. I want to come on again now that now that we're all established. I'll see if I can do good.
Yeah, I'll pitch you to our producer and say we got to get Trace back on now that we've got our podcasting legs underneath us.
It was really fun to come on. We talked about mutants, if I remember correctly, and like X-Men, and it was really great.
Yeah.
Well, thank you everyone for listening to this episode of That's Absurd, Please Elaborate. The show was created and written and produced by me, Trace Dominguez, also Julian Huguet, and this week also written by Ceri Riley. It was produced and edited by the wonderful and probably not a ghost, maybe, our editor and producer, Kyle Sisk. Special thanks to the listeners who submitted questions featured in this episode. That would be Chris from Ontario, but also Julian. So if you want to submit a question, again, go to the show notes. You can email us at hello@that'sabsurdshow.com. Visit our website, that'sabsurdshow.com/ask. You can call us at 302-TAPE-SHOW. You can send us, I think, a comment on Spotify, though I've not actually explored that much. That's pretty new. And special thanks also to our Patreon subscribers. Special thanks to our new Patreon subscriber, Ashley Hamer, who we love. She's the best.
Yeah, I haven't met Ashley, but she's great.
She's the greatest. So she's subscribed to our Patreon today. You can subscribe to, just go down into the show notes, patreon.com/that'sabsurdshow. And a shout out to our 2 absurd administrators, Lee and Les. Thank you for your support. Leave us a review wherever you're listening right now. You know, leave a star or a heart or a little ghost emoji or whatever it is that you want. A firework.
Firework or ghosts for this episode.
Yeah, for sure. And please send us a question. If you have a random question, your kid asks you something you don't know about, send it to us. We'll answer it. We'd be happy to. And remember, fireworky, ghosty things are cool.
Remember, as we say at the end of every episode, if you see a ghost every day, you're gonna get bored of it.
True. You probably would. Yeah. Remember, like we say at the end of every episode, volcano lightning, nature's fireworks, and aerogels are nature's cotton candy, so if you brought them together, you'd be at a carnival.
That's it, yeah.
Thanks for listening, everyone. We'll see you next week.